Hello everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we will study about decimal to hexadecimal number conversion. Currently, in Fundamental of Digital Electronics, we are running a series of video lecture on number system. So far we have studied about decimal to binary and binary to decimal conversion, octal to decimal and decimal to octal number conversion, decimal to binary, and same way octal to binary and binary to octal also we have studied. In this video lecture we will study about decimal to hexadecimal number conversion, and in next video lecture we will study about hexadecimal to decimal conversion system. So now let us start with hexadecimal number. In case of hexadecimal number, we have total 16 bit. In case of decimal, we know that we have total 10 digit 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 10 digit in case of decimal number system. In case of binary number system, we know that we have 2 bit. Either it is 0 or 1. And same way in octal number system, we have total 8 bits. That is 0, 1, 2, 3, 4, 5, 6 and 7. Same way in case of hexadecimal number system, we have total 16 bit, and base or radix for hexadecimal number, that is 16. In case of decimal, we have base, that is 10. In case of binary, we have base 2. In case of octal, we have base 8. And in case of hexadecimal, we have base, that is 16. Okay, now let us understand decimal number and equivalent hexadecimal number. In case of decimal, we have 0, 1, 2, 3, 4, 5, 6 and 7. Same way in hexadecimal, equivalent number is exactly similar, that is 0, 1, 2, 3, 4, 5, 6 and 7. Up to 9. In case of decimal number, we have numbers up to 9. So in hexadecimal also, we have similar equivalent number up to 9. But when we go for decimal number 10, 11, 12, 13, 14 and 15, then in hexadecimal, we can observe at this stage that for 10, equivalent hexadecimal is A. For 11, we have B. For 12, we have C. For 13, we have D. For 14, we have E. And for 15, we have F. As I said earlier, in case of hexadecimal number system, we have total 16 bit. So up to 0 to 9, that is 10 bit, that is exactly equivalent, similar to the decimal number system. And for 10 to 15, for next 6 bit, we have equivalent hexadecimal, that is A, B, C, D, E, F. You must be very much clear that what exactly the difference between decimal number system and hexadecimal number system, right? So when we go for 2 bit, in case of decimal number system, we start with 1 0, 1 0, 1 1, 1 2 like this. But in hexadecimal, we have number single digit number up to total 16 bit. So after 9, we go for A, B, C, D, E, F like this. Now let us study certain rules to convert decimal number into hexadecimal number. We have step 1, that is for the integer value. To convert integer value of decimal into equivalent hexadecimal, we need to divide decimal number repeatedly by 16 until quotient becomes 0 and remainder will give equivalent hexadecimal number. So for integer value we go for a repeated division, like when we converted to binary or we converted to octal, right? Same way in hexadecimal also we go for a repeated division by 16 for integer decimal values. Now we have step 2, and that is for the fractional value of decimal number. So step number 2. To convert fractional value of decimal number into equivalent hexadecimal, we need to multiply decimal number repeatedly by 16. So for converting fractional value of decimal number into equivalent hexadecimal, we have to go for a repeated multiplication. For integer we go for repeated division, that is our ladder system. In case of fractional value, we go for a repeated multiplication. Now let us take one decimal number, and that is integer number. Let us take 1024. We know that how to divide through our ladder system. Now we divide the number with 16. So if we divide 1024 by 16, we have quotient is 64 and a remainder will be 0. Same way when we divide 64 by 16, we have quotient that is 4 and we have again a remainder that is 0. When we repeatedly divide quotient by 16, so we have to divide 4 by 16, but that division may not be possible and we have to write quotient as 0. We can terminate our process of repeated division at this point, and the last quotient, that was 4, that automatically becomes a remainder. So now we have completed our process of repeated division at this stage, and we have least significant bit, we have most significant bit, and we write from least significant bit to most significant bit. So now remainder is available. A remainder will give us equivalent hexadecimal number. We can observe at this stage that in case of very large decimal values, hexadecimal number system is very appropriate, because in very few steps the number can be converted into equivalent number. If we compare with binary, then we have very long process and number of steps. So that is the advantage of either octal or hexadecimal number system, that when word length is more, we go for hexadecimal number system. So how to write, that we know 1024, that is our decimal number, and equivalent hexadecimal number system is 400. So our most significant bit is 4 and then 00. So 400. So that is our equivalent hexadecimal number system. Let us take one more example. 892. We know that we have to use a ladder system. We continuously or repeatedly divide quotient by 16. If we divide 892 by 16, then we have quotient is 55 and we have remainder that is 12. In case of 12, you should always remember that 12 is equal to the C in hexadecimal. We have A, B, C, D, E, F. So 12 is equal to C. If we divide 55 by 16 again, we have quotient 3 and remainder will be 7. If we try to divide quotient 3 by 16, that division may not be possible and we have to write 0. We can terminate our process of continuous division at this stage, and our quotient, that was 3, that automatically becomes our remainder. Now process is similar. We have LSB, we have MSB. We can write from LSB to MSB, and we have 892 decimal number and equivalent hexadecimal number. Now it is 3, 7 and C. So the main point in this example, that is 12 is equal to C, that you should know, right? So this way we can convert any decimal value into hexadecimal number system. Now let us take one fractional value. Suppose we take 0.88. So we know that for fractional values we have to repeatedly multiply the number by 16, and the rule is we take fractional value back for the repeated multiplication, and we take integer values apart, and that integer values, or what we call it carry, that will give us equivalent hexadecimal number. So 0.88 multiplied by 16, that gives 14.08. 14.08. So 14 is a integer value that we have to take as a carry, and 0.08 that we can take back for repeated multiplication with 16. So 14 we have taken aside. 14, that is equal to E. Again, you should always remember A, B, C, D, E, F. That is 10, 11, 12, 13, 14, 15. So 14 is equal to E. 0.08 we have taken back for repeated multiplication with 16, and then it gives 1.28. So 1 is our integer value, we can take aside. 0.28 we have taken back for multiplication with 16, then it gives 4.48. 4 is our integer value, we can take apart. 0.48 we have taken back for repeated multiplication with 16, then it gives 7.68. 7 is again our integer value. 0.68 we have taken back for multiplication with 16, then it gives 10.88. So 10 is integer value and we are taking aside, but 10 is equal to A. That we should always remember. See, now in this case we have to terminate our process of repeated multiplication at this stage. After 3, 4 or 5 steps we can stop or we can terminate our process at any point. Either fractional value comes to 0, or we have to stop the process, or we have to terminate the process after 3, 4 or 5. That depends on how much resolution after a fraction point we need. Here again 0.88, fractional value has come to 0.88. That was, we have started with 0.88. So now there is no use of going for next multiplication, because the same process will repeat again and again. So fractional value will never come to 0, 0. So we have to terminate our process, and we can write the carry or the integer values we have taken apart from top to bottom. We start from the E, then 147 and A. In similar pattern we write our equivalent hexadecimal number after a point, because this is fractional value. So for 0.88 decimal number system we can write, that is point E, 147 and A, that is equivalent hexadecimal number. Now let us take one mixed number. In mixed number we have integer value as well as we have fractional values. So for mixed number we have to do two processes. One is for integer value, that is repeated division, and for fractional value we have another process, and that is repeated multiplication. We have to do two separate processes, and then we have to combine the number, that is equivalent hexadecimal number, with this 2419.78, that is our decimal number. So we start with the integer value, that is 2419. We know that for integer value we have to go for a repeated division by 16. We divide 2419 by 16, then quotient will be 151 and the remainder, that is 3. Again, if we divide quotient 151 by 16, then quotient will be 9 and a remainder will be 7. Then if we divide 9 by 16, then that division may not be possible, and we have to write quotient as a 0, and the last quotient, that was 9, that becomes our remainder. So we have to terminate our process of repeated division at this stage. We know that how to write LSB, how to write MSB, and we have equivalent hexadecimal number for 2419 decimal number, that is 973. We have written 9, that is our most significant bit. 9 is our most significant bit. So 973. Now same way we can do separate process for our fractional value, that is 0.78. 0.78 we go for a repeated multiplication with 16. We take the carry, or we call it integer value, aside, and that carry or integer value will give us equivalent hexadecimal number. So in this case 12 is integer value. We are taking aside 12 is equal to C. In hexadecimal we know 0.48, that is fractional value, we are taking back for multiplication with 16. Then it gives us 7.68. We are taking 7 integer value apart. 0.68 again we are taking back for multiplication with 16. We have 10.88. 10, that is equal to A. We are taking integer value aside. 0.88 again we are multiplying with 16. Then it gives us 14.08. 14 is decimal integer value, and 14 is equivalent hexadecimal is E. So we have to write E. 0.08 again if we multiply with 16, then it gives 1.28. 1 we are taking integer value aside. Say now we have completed 5 steps for repeated multiplication, but still we have not received fractional value as 00. So we can terminate our process at this stage, right? And we have equivalent hexadecimal number for fractional value. For decimal number we have C point, after a point we have C7AE1, right? We write from top to bottom, top C7AE1. So in same pattern we write our equivalent hexadecimal number, and for total number, that was 2419.78, we write equivalent hexadecimal as a 973.C7AE1. That is our equivalent hexadecimal number. So I hope that decimal to hexadecimal number conversion system is very much clear to you. Do some practice on your own. Thank you very much for watching my video. Keep watching. Thank you very much.